All right, let me tell you a little bit about coordination complexes, which are kind of an area of chemistry that falls into the category of inorganic chemistry, right? Things that are not organic. So in order to give you some explanations for these coordination compounds, I have to give you some definitions first. So here are some basic definitions. Okay, a complex is something that has a central atom in it, right? Something in the middle, which is surrounded by ligands. And the ligands are the things that are bonded, usually with Lewis acid-base kinds of coordinate covalent bonds, to the central atom. And the central atom could also be an ion as well. Okay, so the coordination number is the total number of points where those ligands connect to the central atom. And you can have a compound called a coordination compound that consists of one or more of these complexes all together. Okay, and so it's a little bit of definitions and terminology, but I want to make sure you get them, right? Complex, coordination number, and coordination compounds. So let me give you an example. Okay, ligands usually have lone pairs that can be donated to the central atom. Okay, and so usually the lone pairs that are donated are the Lewis base, and the central atom that receives them, or the ion, is going to be the Lewis acid. Okay. Chelation, which is kind of from the Greek word for claw, right? So imagine something kind of coming out and grabbing the central ion, right? So these are the ligands that are grabbing the central atom or the central ion, is used to describe this complex that forms between the central atom and all the ligands that are surrounding it. Okay, and so here's an example. Platinum 2+ is being chelated or coordinated by these lone pairs, there are 4 of them, on these NH2 groups. Okay, and so we would say that this arrow represents a coordinate covalent bond, or sometimes called a dative bond, between the lone pairs, which are the Lewis base, and the ion over here in the center, which is the Lewis acid. So now, how do you name these things? Okay, well, first we name the ligands, and then we name the metal. Okay, and so for example, if you had a copper ion in the center with 4 ammonia ligands, this is called tetraamine, 2 M's for ammonia, copper 2 ion, right? The II in parentheses is Roman numerals for 2, and the word amine is what I'm going to be using to represent ammonia, NH3. If I have multiple ligands, I go in alphabetical order. Okay, but when I go in alphabetical order, I ignore the prefixes. And I always list things that are negatively charged before things that are neutral. Okay, so for example, here's a complex ion that has a cobalt in the middle and some different ligands, right? There's chlorine, there's water, and there's ammonia. So the chlorine is really chloride, right? That's negatively charged. The water is neutral. I call it aqua for water. And the ammonia is neutral, right? I call that amine with 2 M's. Okay, and so this would be diamine, because there are 2 of those, diaqua, because there are 2 of those, dichloro, cobalt 3 ion. Okay, how do I know that it's cobalt 3? Because the whole thing has a charge of +1, and each of the Cl's is -1. So if I have 2 Cl's, that gives me -2 overall. So if the cobalt were +3 and I added -2, I would get +1. If the ligand already has a prefix, then we have to use a different prefix for how many ligands there are. Okay, and so here we have to use some kind of Greek terminology. Okay, bis means 2, tris means 3, and my favorite, tetrakis means 4. Okay, and so for example, this ethylene diamine that you saw a second ago that was bonded to the platinum, okay, if I had 2 of those, since there's already di in the ethylene diamine, I can't use di again, so I use bis instead. So this is going to be bis, parentheses, ethylene diamine, platinum 2 ions. Right? En is my abbreviation for ethylene diamine, which basically has 2 amino groups separated from each other by 2 carbons. Now, if I have a complex ion, I can name it by just adding the letters ate, A-T-E, at the end, and I have to use Latin names for copper, gold, iron, lead, and silver. Okay, if you're not familiar with these, copper, Cu, is cuprum, so this would be cuprate. Okay, gold is aurum, so this would be aurate. Iron is ferrum, so ferrate. Okay, lead, plumbum, okay, so plumate. And silver, argentum, so this would be argentate. Okay, so for example, CuCl4, 2-, is the tetrachlorocuprate 2 ion. Even though there are all these rules, we still use some common names that you should be familiar with. Okay, so for example, K4 FeCN6 is simply called potassium ferrocyanide. Okay, and so this potassium ferrocyanide has in it Fe2 plus ions, okay, in the center. But if I had ferricyanide with an I as opposed to an O, okay, this has Fe3 plus ions. That's the difference. And you see the difference in the formula here. It's K3 FeCN6 instead of K4 FeCN6.